All right. Good morning. Happy Thursday. All right. So a couple things. First of all, I mentioned yesterday I'm sending out progress reports tomorrow. It does not necessarily mean that you're failing. It means that if you continue not doing assignments, continue being absent, continue not getting a low test grade, you could possibly fail. It's kind of like a wake-up call. So it's mainly like just, do I need to be doing something better? Also, just a reminder, there's no school on Monday. So no school on Monday, right? Or do we have school Monday?
No, we don't.
No, we don't. So 2 Mondays in a row. So thank you. So just remember that next week we're following this same schedule. So we're following that Monday holiday schedule. So just to let you know. So don't forget, Monday, no school. So the next time I see you will be on Tuesday, right? So Tuesday. All right. So the last time we were together, I taught the steps for solving a polynomial inequality. And what I did is I posted these steps in your assignment, but I also posted it in materials in classroom. And today, you're going to see something similar that I have not posted yet because I don't want to confuse you. Here's steps for solving a rational inequality. So I have not taught this part of the lesson yet. Okay, so I asked you to do problems 1 through 41 odd. And now I'm going to teach 43 through 59 odd. All right, so before we get started, do you guys want to ask me any questions? Now, okay, so let me tell you something. So somebody said, Miss Birch, is it always true, false, true, false, true, false? When you do the number line, when you break it into intervals? And the answer is no. Most of the time it is true, false, true, false, true, false. But guess what? I was doing a problem in period 2, and there was a problem that had multiplicity. So it looked like this. It looked like x minus 2 times x minus 2 times x plus 5 when I finished factoring. Will you see that right there? The solutions would be 2, 2, and -5. Well, guess what? When I did that, when I broke it into parts, it wasn't true, false, true, false, true, false. It was true, true, false. So this is a cubic. And so what's happening is at -5. Okay, so at -5, it's crossing, but at 2, it's doing that. And so anyhow, to make a long story short, what happens is this is either going to be true, true, false, or true, false, false. So anyhow, just to make you cognizant of multiplicity, the multiplicity means you're going to have to check all 3 parts, you know, when you break the number line up. So be careful, all I'm telling you is be careful of multiplicity. Okay, now, before we get started today, does anybody want to ask me any questions about solving a polynomial inequality? Anybody need me to do something? Any questions about anything, any parts of this? Okay, can I get some responses from you guys? Can you guys just kind of chime in and let me know, yeah, you get it, or?
Yeah, we get it. The notes that you gave us were pretty understanding.
Thank you. Thank you. Well, at least I'm doing something right. All right. Thank you. All right. Anybody want to ask me any questions about any problems, or anybody need clarification on anything? Okay, well, I have not posted this yet. So I'll keep holding it up, but I will post it. And these are the steps for solving a rational inequality. Now remember, a rational inequality is not a polynomial. Remember, a polynomial is a smooth curve. Okay, remember, rational means there's a variable in the denominator. So rational rhymes with fractional. So we're dealing with fractions. All right, so let's try, I don't really have anything to tell you. Let's just do some examples. So let's just do a lot of examples and see how it goes here. So the last time I was with you, I taught one objective, and that was solving polynomial inequalities. Today, I'm going to teach another objective, solving rational inequalities. Rational or fractional inequalities. Okay, I'm gonna pin myself so that I can see what you guys are seeing. Okay, just a reminder, don't be late to class. I am making very important announcements at the beginning of class, and before I kind of gave the announcements in between so you'd hear them, but you're missing important announcements. Don't be late to class. All right. So this is 3x plus 3 divided by 2x plus 4, and that's rational. And it's not because it's just a fraction, because if you had this, that's linear. So this really means 1/2 x plus 7. So the variable is not in the denominator. So I'm not saying just because it has a fraction, it's rational. I'm saying because there's a variable in the denominator, it makes it rational. So you remember what that means? That means that we could have a vertical asymptote or more than one. We could have a horizontal asymptote. So what I taught before is going to come into play here. All right, so this is a rational inequality. And remember what I said about these symbols. 2 dots are greater than 1, so that's greater than. 1 dot is less than 2, that's less than. So we have this rational inequality greater than 0. Now, do you guys remember what I said about the inequalities? The inequalities have infinite answers. So it's not like an equation where you have a couple of answers, 1 or 2, 3, whatever. This has infinite answers. Okay, so the first step, we're going to do the same exact thing. We're going to set the inequality. We're going to put 0 on one side. Now, this one's already done for you because there's already a 0. So if you have a problem that doesn't have a 0, if you have your books open, like problem number 55, number 56, number 57, 58, 59, 60, you're going to have to set it equal to 0. And worse than that, you're going to have to get a common denominator and add fractions. All right, so anyhow, okay, so the first step is setting it greater than or equal to 0 or less than. Okay, the second step is we're going to do, well, it's a little bit different. We're going to set the numerator equal to 0 and the denominator equal to 0. So let me show you. So we're going to set the numerator equal to 0, and I'll tell you why. And we're going to set the denominator equal to 0. So in other words, we are not dealing with the inequality right now. We're doing something else. So we're going to deal with this inequality later. And you know what? I'm just going to put the inequality in red, because later we're going to look at it. All right, now guess what we're going to do? Remember what I taught in the past? Remember when I set the numerator equal to 0? Do you guys remember what we found? Remember we found the x-intercepts? And remember when I set the denominator equals 0, we were finding the vertical asymptotes? That's what we're doing. So this isn't new. So here we go. So you're going to solve for x by subtracting 3, and then when you divide by 3, you get x is equal to -1. Now the question is, what is that thing? Well, that thing is a solution, which means it's an x-intercept. So this is left 1, 0. This is an x-intercept. Let's write that. Over here, we're going to find a vertical asymptote. So look at this thing. This is an equation, right? Can I divide everything by 2 if I wanted to? Divide by 2, divide by 2, divide by 2 if you want to simplify right away. So when you subtract 2, you get x is equal to -2. Now, your answers look the same, but you found two different things. Over here, you found an x-intercept. Over here, we're going to leave it like that because we found a vertical asymptote. So this is what I taught in the past. So now what we're going to do in step number 3 is we're going to, like we did with the polynomials, do the critical points. So remember our critical points? Well, so now not only are we using the solutions, we're using the vertical asymptote for our critical point. Crazy, right? So watch. So I'm going to put a critical point at -1. That is not an asymptote, by the way. And we're going to put a critical point at -2. So they're kind of close together. Okay, now what we're going to do is we're going to test points like we did before. And I always like to test 0 when it's available. And we're going to put it into the inequality, which is a big mess. So here we go. So this is going to be 3 times 0 plus 3 over 2 times 0 plus 4. Is that greater than 0? So anything times 0 is 0. So this ends up being 3/4. So is 3/4 greater than 0? True. Now, we're thinking it's going to be true, false, true. I have to test a fraction, which I really don't want to do. But I'll just show you how I do it in case you have to. So I'm going to test -1.5, which is really -3/2. So let me just show you how it works. It would be 3 times -3/2 plus 3 divided by 2 times -3/2 plus 4. Is that greater than 0? See what a pain this is? So up here, this is going to be -9/2 plus 3, get a common denominator. And on the bottom, the 2's cancel, so you get -3 plus 4 is 1. So we get rid of the fraction, so that was cool. So now we have -9/2 plus 6/2 is greater than 0. So is 3/2 greater than 0? And that's true? Really? So true, true. Hold on a second. Oh, it should be -3/2. -3/2. So that's false. So this fraction in there is false. And I'm going to assume that's going to be true. I'll test it real quick. So I'm going to test -3. So that's going to be 3 times -3 plus 3 divided by 2 times -3 plus 4 Is that greater than 0? Is, okay, negative 9 plus 3 is negative 6, and negative 6 plus 4 is negative 2. So that ends up being positive 3. So it's true like I thought. All right, so can I erase this over here? Are you guys there? Okay, I'm gonna erase all this.
Yeah, that's fine.
Okay. I'll be so glad when I can have I have like 9 boards in my classroom instead of these 2 little boards, but I am thankful that I was able to steal these from GK because these boards are about $400, the boards I'm working on right now. And so I wouldn't have been able to afford that probably. So I'm glad I was able to steal them. All right, so number 5 is our answers, and here's what we're going to write. So we have, let me draw it. It was greater than, so it's open going to the left, and it's open going to the right. And so our solutions are negative infinity up to negative 2 open, or open on negative 1 to infinity. So those are our solutions. And they want us to show this on a number line, then I'm going to show you what it really looks like in 2 dimensions. So the number line is similar to what we have there. So it's going to be open on negative 2. So we're using the Precalculus notation. Open to the left, color. Open on negative 1, color. Now I want to show you what this looks like in 2 dimensions. Now check this out. This is cool. So once again, if you're wondering, why didn't I graph this in 2 dimensions? Because we only have an X. But look what this would have looked like in 2 dimensions. We would have had an asymptote at negative 2, remember? And there would have been an x-intercept at negative 1, and this is what it looks like. This is the rational function. And can you guys see the solutions? The solutions are to the right and to the left. Those are your solutions. So this is what the graph really looks like. So remember we had a vertical asymptote, and there was a hole at negative 1. Now you don't have to draw this. I just want you to see this. This is all you have to do up here. You don't have to do this. I just wanted to show you what the actual inequality looks like. So in other words, because of that symbol, there were infinite answers, and that's how the infinite answers look. It looks like open on negative 1 to the right forever, and it looks like open on negative 2, the asymptote, to the left forever. Okay, let's try another problem. Okay? Now, like I said, the hardest thing for you guys is just going to be the basic math, this stuff over here. So, and that's because, you know, of not having a good foundation in elementary school, middle school. So that's the deal. You know, a lot of times people say, Ms. Birch, I know what you're doing. I know exactly what you're teaching, I'm just having trouble getting through the basic math. So that's very common. So that's why, we just want to improve as time goes on, just get better and better at things. All right, now check this out. I'm going to do one of the harder problems where it's not set equal to 0. So watch. X plus 1 over, that's rational. And look, it's greater than or equal to 2. Well, we don't want that. So remember, we have to set it equal to 0. So look what I'm going to do. I'm going to subtract 2 from both sides. And with this, you guys, you have to get a common denominator. So you have to multiply that guy by the common denominator, x plus 3 over x plus 3. Right? So your common denominator is x plus 3, and on the top, you have x plus 1, you have to distribute, minus 2x minus 6. Hold on, this should be 0, right? Subtract 2. So now you have negative x minus 5 over x plus 3, and now you're ready to start the problem. So we had to do all that work just to start the problem. So all I've done, you guys, is I've just set the inequality to 0, number 1. So remember what we're doing on number 2? We're going to get the x-intercepts and the vertical asymptotes. So we're going to take, now the numerator is negative x minus 5 over, or equals 0. And x plus 3 equals 0. So we're setting the numerator and the denominator equal to 0, number 2. We're going to solve them. So when you add 5, you get negative x is equal to 5. So x is equal to negative 5. So that right there is an x-intercept. When you subtract 3, you get a vertical asymptote. And these guys are critical points. Now, if we were graphing, this would be an x-intercept, that would be an asymptote, but with these inequalities, these are our critical points, both of them. So we have a critical point at negative 5. And we have a critical point at negative 3. And all this is doing is it's dividing the number line into 3 parts. And now we're going to test for solutions. So we're going to test 0 over there into this. So we have negative 0 minus 5 over 0 plus 3. Is that greater than or equal to 0? Is negative 5/3 greater than or equal to 0? That's false. Okay. Now we're going to test negative 4. So this would be negative of a negative 4 minus 5 over negative 4 plus 3. Is that greater than or equal to 0? So that's negative 5 plus 4 is negative 1 over a negative 1 is a positive 1. So this one was false. This one is true. And I'm just going to guess, since there's nothing fishy going on, I'm just going to guess that's false. And you can test it out if you want to. Now, I'm going to give you a hint about something. Listen up. From the last picture that I drew, this means above the x-axis. Less than means below the x-axis with these guys. So that right there means above the x-axis of the solutions. So this means the solutions are above the x-axis. We're going to find out. Okay, can I erase this right here or no?
Yeah, that's
Okay, so I'm just going to erase this part. I'll leave that. So now we want to write the solutions. And I'm going to mark them over here. So true is going to be closed, closed, and shaded. So our solutions are closed on -5 up to -3 closed. Pay close attention here. Pay close attention. Everybody look over here. Isn't x equals -3 in the graph? Isn't x equals -3 in the real graph? Isn't that an asymptote? So shouldn't this be open? Because you can't hit the asymptote? That's a little tricky. That's a little tricky. You might want to make a note. This is open because of the asymptote. And the graph for the number line is going to be -5, -4, -3, -2, -1, 0, 1. It's going to be closed on -5, and on -3, it has to be open. And now I want to show you what the real graph looks like. Now, notice, remember what I said here. This has to be above the x-axis, so watch. Bernie, can you mute yourself? Somebody's unmuted. I'm getting a lot of stat. Bernie, can you mute yourself, please? So in the real graph, we had a vertical asymptote at x is equal to -3. And we had a solution, if I'm not mistaken, at -5. Well, if you put this on the calculator, you graph this, it looks like this. And look at our answers. It says closed on -5. So see how that's above the x-axis? And that was the only part of our answer. This isn't part of the answer. So the answers are above the x-axis. So you see how calculator wouldn't help you out? A calculator is going to draw this, but you have to know that the solutions are above when it's greater than or equal to. Now, if it had been strictly greater than, this would have been open. But because it was greater than or equal to, it's closed. But do you see why we had to open that? Because that's a vertical asymptote in the real graph. That's the lesson, you guys. You guys, I'm done teaching. I'll be happy to work. We can work a problem out of your book if you'd like. We're going to work in the teams. But I can work some more problems if you want. Go ahead, Bernie. Question.
Oh, no, I was gonna ask. For the
Edward?
fraction,
Yeah.
is the top number always gonna be a x-intercept and the bottom a asymptote?
Yes. So the numerator is always an x-intercept, and the denominator is always a vertical asymptote, right? Now notice that we're not dealing with any horizontal asymptotes because we're not graphing. So we're not concerned about those. We're not concerned if they cross or they don't or whatever. In fact, on this problem, there might be a horizontal asymptote at y equals 0, so you can cross a horizontal asymptote sometimes, but I'm not sure and we don't care. So the only reason I'm showing these graphs right here is so you conceptually know what's going on. You don't have to draw this. And like I said, the reason why we're doing, see, a number line is one-dimensional. So if you and I, let's say we were neighbors, we all live on the number line. Do you realize that I can't go down the street unless you guys back up? So it'll be like, Edwin, Brandon, can you guys please back up so I can get down the street? When you live in 2 dimensions, I could just go right and up. But when you live on a number line, you only go left and right. Well, the reason why I'm saying this, if you look at these problems, there's only an X. So there is no range. It's not 2-dimensional. There is no Y. So that's why we're staying on a number line, because we're only dealing with X, we're not dealing with Y. This shows the Y. We're not doing that. So we're only concerned about the domain, the solutions that go left and right now. Okay, let's do another problem. Somebody pick a problem, and we'll just go step by step and see if you can do each step. Pick a problem between 43 and 59 in less than 2/7.
49.
Okay. All right. 49 is 4 minus 2x divided by 3x plus 4. So this is rational because of the variable on the bottom. Less than or equal to 0. So that means that in the real graph, the solutions are going to be below the number line. All right. Now, we don't have to do anything with the setting it equal to 0 because that's done, right? All right, here we go. Here's the second step. you're going to set the numerator and the denominator equal to 0. So I want you to do that and tell me what you get. So you're going to set the numerator and the denominator equal to 0. Okay, solve for x. All right, when you're done, shout out what you got for the first one. So what'd you get for the first one?
+2.
Okay, I'm just going to write it over there. So let's see what we get. So I'm going to subtract 4. Subtract 4, subtract 4. I'm going to multiply by a negative and multiply by a negative because I don't like all those negatives. When you divide by 2, you get 2. Now, what did we find, you guys? It's going to be a critical point, but what is that thing? When you set the numerator equal to 0, what did you find? Did you find a solution or did you find a vertical asymptote?
A solution?
Yep. And a solution is also called an x-intercept, right? Okay, let's go over here. Somebody shout out what you got over here. What'd you get over here? Go ahead, I'm listening.
-4/3.
-4/3. Okay, let's see. So you subtract 4, divide by 3, divide by 3. X is equal to -4/3. That's correct. Now, what did you find there? Did you find a solution or a vertical asymptote?
Asymptote.
So remember, if our graph lands on that, it has to be open because you can't hit a vertical asymptote. So here we go. So these are critical points. So you're going to draw a line through 2. You're going to, isn't -4/3 -1 1/3? Yes? Guys with me? All right, now, why did we do this? We're dividing the number line into 3 parts and we got to test the parts, right? So what do you guys want to test first?
Three.
3, okay. So this would be 4 minus 2 times 3 over 3 times 3 plus 4. Is that less than or equal to 0? So 4 minus 6 is -2. And this is 9 plus 4 is what, 13? Is that less than 0? Yes, it is. So that is true. Right? 3. What do you want to test now?
0.
Good. So we have 4 minus 2 times 0 over 3 times 0 plus 4. Is that less than or equal to 0? So this would be 4 minus 0. This would be 0 plus 4, which is 1. Is 1 less than or equal to 0? False. So take one guess what these are going to be.
True.
Yeah. And you can test it if you want. Okay, can I erase this over here? Let me draw this first. This is less than or equal, which means closed on negative 4/3 this way. And this is less than or equal to it's closed onto for the true part. What does true mean again? What's true mean? What's false mean? What's it mean? Go ahead, don't be afraid. What's true mean? What's the red mean? What's it mean?
It's a solution.
Yep, these are all solutions. 3, 4, 5, 6, 10, 20, 1,000, a million, a trillion. Over here, -3, -4, -5, -6, -1 million, -1 trillion. What does false mean?
They're not solutions.
Right, so give me some examples. What are not solutions, class?
0.
0, what else?
0.1.
0.1, 0.112, 0.00001, 0.0000001, 0.99999999999999999. No solutions. All right, so over here, our solutions then are negative infinity up to negative 4/3 closed, or closed on 2 to infinity. Yeah? And is this right? Can this be closed on an asymptote? So what should we do? Right? Because of this? And then this number line isn't exactly right. Because shouldn't this be open on negative 4/3? And closed on 2. So a little trick. You want to watch out for that, right? And I am checking my book, by the way. And that is absolutely correct. And our graph is absolutely correct. Okay, here's what we're going to do. You ready? I'm going to give you 2 problems. I'm going to give you a polynomial inequality, and I'm going to give you a rational inequality. And at the end of class, you're going to come back and we're going to see if you got the right answers in your Math Wizard teams. All right? All right, so here's your 2 problems. All right, so class is over at 10:45, and you're going to come back at 10:35. So write that down. You're coming back. Anybody want to ask me a question before I erase this? So like I said, this is not that hard. You just got to be good at, the basic math stuff. All right. Now, if you've already done this problem, fine. I want you to do it again in your team. You're going to do problem 25. And you're going to do problem, let's do 51. All right. I'm going to be taking attendance in the Math Wizard team. And what I want you to do is make sure that you follow these steps and look at your notes. And we're going to see if you can get the right answers on these two problems. All right. Okay, I'll see you back here at 10:35. Call me if you need help.
Miss Birch,
Yeah.
I know I don't have my camera on, and I just want to let you know that my laptop had broke, like its charger had broke. So I'm using my stepdad's computer, and he doesn't have a webcam.
Okay, but you're gonna get it resolved, right?
Yeah. My mom said she will get me a new laptop charger next week. In this
Yeah,
week.
no problem. I won't
Okay.
call home then. Thanks for letting me know.
Yeah. Okay.
All right, hon. Thank you. All right, welcome back. Well, I just randomly picked two problems, and number 25 was like the hardest problem in the book. It was the one that I put in the notes with the radicals. So the bad news, I gave you a problem I did in the notes, and the good news is we did do it in the notes, so you didn't have to do it. So next period, I'm going to give them an easier problem than that. But let's take a look at problem number 51. The first step is already done for you. The second step, you're setting the top equal to 0, and you're using the solutions. And you're setting the bottom equal to 0, add 3, and you get the vertical asymptote. Can you guys mute yourself, please? On the third step, you're drawing a number line and you're dividing it into parts to find out what parts to test for solutions. So you're going to draw a line through 0 as a critical point, and 3 is a critical point, but also remember this is a vertical asymptote, so your answer cannot have a 3 in it. So in step number 4, we're going to test some points, and this time I cannot test my favorite number 0 because it's a divider, it's a critical point. So you cannot test a critical point. So you have to test numbers on either side of the critical point. So I'm going to test it into this. So I have, is 1 over 1 minus 3 greater than 0? This is 1 over a negative 2. So a negative is not greater than 0, so that's false. Now I'm going to test 4. So this would be 4 over 4 minus 3. Is that greater than 0? Is 4 over 1 greater than 0? That's true. So I'm going to assume that's true. So now we write our solutions. Actually, let me draw this first. So we're saying that if this is true, that's greater than, this is going to be open to the left, our solutions, and open on the right, our solutions. So my solutions are going to be negative infinity up to 0 open, or open on 3. And by the way, it's a vertical asymptote, right? So it had to be open to infinity. And our solution graph should be open on 0 to infinity to the left and open on 3 to the right. And let me check my answers. So negative infinity up to 0 open or 3 to infinity. So this was it. How many of you guys got this? Good, good, Adrian. Georgina, yeah, good. So not so bad, right? Now listen carefully. If this had been greater than or equal to, this would have been closed and that would have been closed. But remember, you have to open it because that's a vertical asymptote. So that little greater than or equal to would have caused those guys to be closed, bracket. But you would have had to leave this one open because of the vertical asymptote. Do you guys understand what I'm saying or no? Yeah? Yeah. Can you guys shake your head yes or no? Yes. Okay. All right. Well, listen. I did post the assignment, as you probably saw it. These are included in the assignment, but I did post them also in materials so that when we leave the assignment, you still have those in the read them. Make sure that you use your notes. I gave really good notes, and make sure you follow these steps. And this assignment, I think I made it due on Tuesday. Remember, no school on Monday. So no school on Monday, and this is due at 11:59 on Tuesday. All right. All right. Well, I hope you guys have a great day. Okay. Have a great day. Have a great weekend.
Bye, Miss Birch. Have a good one.
Bye, guys. Bye, guys. Have a good one.
Thanks, Birch.
Bye, Edwin. Bye, you guys. Have a good day.